Next thing we need to do is set up IORates. In this particular case, I've used Notepad from my command window on my Pi3 server to create a text file with commands and data for the PyConfig utility. You could do this also with the system management tools for Pi3. What I've done is I've selected my table and point class, set the mode to create true. I can use the same file for editing then in the future. And I've created some tags here. I'll explain what these three tags are in more detail in a moment, but I've got a snapshot rate for Bobcat and an update rate for Bobcat. Bobcat's the name of my PINet node. And then Fractal's my interface or simulation program over here. And I ran PyConfig from the command line, redirecting my text file as input and capturing the results as output. And then I typed the output here, and we can see that I successfully created 3 tags. Let's see what this looks like on the VMS side. On the VMS side, there's a utility called WildL, and I can type in sy.io.star, and that should get a list of the points if they exist over here. Note something interesting. For each point, I've got 2 ID numbers. There's an SYIO Bobcat, SYIO Bobcat EV, SYIO Fractal. And then I've also got a name here, looks kind of funny. We call this the commingled tag name. Tag names in a PINet node are internally stored using 10 characters. If the tag name's longer than that, we artificially create a short name that we call the commingled tag name. The commingled tag name is similar to the 8.3 tag file names that you find in Windows. So what we've done is we've taken the first part of the long name, a tilde, and a number, where the number is the point ID for the point. These commingled names are going to be important in a moment because I'm going to want to edit a file called IORates.dat to create a table that references a Pi tag name. It's got to be a short tag name to a counter number. The interfaces on the or sources of data on the PINet node can use a counter number to report the IORates. The PINet node has up to 200 counters. The counter numbers are unique per node, so I can use counter number 1 on one machine, and that's different than counter number 1 on the next machine, and so on. Some of the counters are reserved for use by the PINet software itself. The reserved counters are in the range of 35 through 50. So let's take a look at the IORates.dat file. So here we can see that I've edited the IORates.dat file, and I've added lines here for SYIO Bobcat and Bobcat EV and Fractal, and I've set the counter numbers. But notice I used the long name, and what I'm going to have to do is scroll my screen back up here to figure out what the short name was and use that. So I'm going to see if I can copy this and paste it in here. And I'm going to comment out the original line just so I've got it there for reference purposes. And I'm going to paste it again. Since I looked ahead, I know that this is going to be 2. And again, I'm going to comment out the instance of the long name. And I need to do something also with this one. I think it's SR tilde 3, 40. Now the Fractal program is using counter number 40, which is in that range that I said was reserved for use by the PINet programs. Turns out Fractal's one of the programs that is allowed to use the counters in the reserved range. If I were using something like a chip-to-Pi interface or a VG interface or one of the others, I'd need to stay away from the 35 through 50 range. So I've set up my IORates.dat file here. I can Control-Z to save and exit my file. Unlike interfaces, the IORates subsystem on a PINet node, here's the IORates subsystem, it doesn't automatically sign up for updates. In order for it to sign up for updates, it would need to be checking that IORates.dat file for changes. So in order to tell IORates that I changed its configuration file, I need to stop and restart the IORates subsystem. And I can do that just like stopping an interface. I can say at PINet stop IORates, and then when it's stopped, then I can just restart it. So it's a very quick process. If I wanted to know how to do that, I could have used a search command or the edit command to take a look at the PINet-start.com file to see how Pi starts and stops IORates. Or I could have checked the manual, but I was in a hurry, so I just did it. There's an IO monitor utility on a PINet node. This is similar to the output you see perhaps with PiARTool-SS on a Pi server. With IO monitor, you can specify a scan period. 5 seconds is typical, and it shows you the output. In this case, I've misconfigured something in my IORates.dat file. I'm probably missing a comma somewhere, so I need to edit that. So I'll fix that and we'll come back.